Good.
All right, so my name is Alexander Marks. I'm the team lead for UCI's CargoPlane. CargoPlane is a SAE competition that is a global competition where schools from all around the world come to compete. Other people in this room might be in other SAE competitions as well. So our advisor is Professor John T. LaRue, and our other sub-advisor is Colin Sledge. Some of you guys may know him as your TA for some of your classes. Over here is...
I'm Austin. I'm the tail lead.
I'm Paul Yap,
and I'm the controls lead.
I'm Patrick. I'm the fuselage team lead.
And I'm Isaac Ortega. I'm at the wings lead.
We have 27 members on our team, and each lead has a certain number of members underneath them. Okay, so here's our plane design. This is actually pretty much our finalized design. Our technical report is due this Sunday, and we've already been manufacturing this, and a good chunk of it has already been completed. We'll talk further about the design later, but for the most part, we've had a few different, there's some rules that we have to go by in order to determine which airplane, or how to design the airplane. So background, I've already talked about the competition a little bit. Basically, we have a 55-pound takeoff weight limit. We have a 1,000-watt maximum power output from the motor, and we have to have a limit of 12-foot wingspan, and we can't use anything but metal and wood. So we have to basically use simplistic designs and semi-basic tools. We can't use like carbon fiber and other composites like that, and so we have to think about how can we reduce the weight of this wood using like truss designs and cutouts and things like that in order to maximize the efficiency of it. So in order to get started, we had our plane design last year. Last year we placed 17th overall. We got second in design report. We got 11th in the takeoff and the actual flight portion, and we didn't do so good in the presentation aspect, but so far we've been trying to improve that. We docked a lot of points last year because of last minute changes, which is what we tried to prevent this year, because after you submit the technical report, you're required to, any changes after the technical report, you lose points overall in the competition. These are some of our classes that are the preferred prereqs. They're not required, but they're the ones that are useful for doing analysis and designing things on the project. And then our motivations, we want to represent the school in a competition. We want to do well so that we can make UCI proud and come back with a trophy and represent the school. And so we wanted to design a winning plane, and we wanted to teach students about materials and structures, simulation analysis, technical report writing, and manufacturing techniques. So our goals and objectives, as I mentioned earlier, we had to do things like we did fly in the competition. We're actually required to submit a technical report, 30+ pages this Sunday. And then we have to present also in front of a bunch of industry associates from Lockheed Martin and Dassault Systems. Our objectives this year were to improve the design last year by reducing the weight of it by 25%, which we actually managed to do. We wanted to design a wing that generated more lift than last year, and we wanted to also improve the volumetric efficiency because last year we had a lot of wasted space and weight. So another thing that we didn't do last year is we didn't have that much time to have test flights, and we didn't actually build our airplane until after the technical report deadline. So this year we tried to not do that. So we didn't get to actually do that. We haven't completely built an airplane, had a flight yet, but I mean, we're doing better than last year, so there's a lot of improvement, so it's okay. But I'm gonna go ahead and let Isaac talk.
Okay, so in terms of organization, we have, as previously mentioned, 27 team members. So we have 2 advisors and also 5 team leads. So every week we have two gatherings, 2 meetings. So we have one where it's only the team leads, and then we also have a general meeting. So during the team leads, we will just get together and fill in like what we've been doing throughout the week. And then in the general meeting, we tell everyone else what's happening and then what tasks had to be done for the current week. So, an example would be for my team and the wings team. We had to design the spars to be as light as possible. So, during the team's lead meeting, we would have Professor LaRue gives us suggestions of different things we could do with the design, and then from there, I will assign my team my team to do different tasks. So there was a lot of stuff to do, like with different cost sections, also materials. So from there we would do FEA analysis, and then from there we determined to have all a wood, a spar made entirely of wood. So that's how generally other teams would perform their work also.
Alright, so for the design requirements, as mentioned before, we do have a max takeoff weight of 55 pounds. That includes both payload, the cargo, and the plane. So the lighter we can make our plane, the more we can carry, as well as 1,000-watt max power from the motor. We have a limiter set by the SAE that limits the power that we could use so that everybody's even. Also a 12-foot wingspan. With the wingspans, we really focused on creating a bigger surface area, so a little bit wider instead of longer, so that we can increase the surface area, which would give us more lift and be able to carry more weight while reducing weight of the plane. For the controls, we just followed the requirements. So for that, for the motor, we picked a motor that could do at least 50% more of the requirement, which was 1,000 watts. So we picked an 1,800-watt motor to keep from redlining. Battery, we picked a 4,000 milliamp hour battery so that we could have multiple runs. Fuselage, wings, and tails, we really focused on changing the different materials for different parts, such as joints, just to reduce weight again. We also did a lot of techniques such as creating bulkheads and making cutouts. I'll be passing it over to Alex again to cover the
Next slide.
yeah.
So this is engineering principles that we used. So what we did first is that we researched, and we started with last year's airplane. We went back to the competition, and me and Isaac are the only two people who returned from the 30-person team last year, so it's kind of back to square one a little bit. But we went and researched and looked up Facebook and YouTube videos of other teams' airplane competition designs from last year and see what they did and how they manufactured and how we could go about trying to possibly improve our airplane design. We also looked at real airplane designs and saw how they designed their structures and stuff like that. You know, it's really hard to do like swept wings and winglets and really complex designs because all we have is wood and metal to use. We've already mentioned design requirements many times. Feasibility, the main thing about the feasibility is that how fast can we build it, how well can we manufacture it, were we able to do it in a reasonable enough time and with ease to be able to do multiple revisions, and how much was going to cost us, because right now it's actually not that much to build an airplane, but the main thing is all the money put into the controls and the receiver and the radio and things like that. That's the most expensive part. Buying balsa and birch and poplar is cheap, but electronics are not. Conceptualized, so we sketched different airplanes, we sketched different payload ideas and cargo ideas. How are we going to get, insert and remove the payload and the cargo quickly? What type of airflow shapes do we want to go with? Wingspan, we were keeping the same length, but we wanted to change up the chord ratio, the span ratio a little bit. So also last year we had all aluminum spars, and we were able to reduce the weight of our wings from 8 pounds to 5 pounds this year, just because we went to Sitka spruce wood spars, and we ran simulations to determine the minimum dimensions required to withstand the loading and not break under that shear force. For preliminary design, like we said before, volumetrically efficient, minimize weight, more control surfaces. Last year we had issues with controls. This year we drastically increased the size of our tail. Structural integrity, maintain our strength while reducing weight with trusses and cutouts. And can we substitute other materials that are lighter in order to, and still maintain that strength that we want, so that we can reduce the weight. And just lots of calculations. Then we made a bunch of SolidWorks models, revised the SolidWorks models. We bought electronics, we simulated the total weight to find the CG. And then for manufacturability, we went around and looked at websites and local people, and we made phone calls and saw, okay, what can we get, what can we buy? We don't want to have to custom order anything. We need to be able to just purchase it readily, and so we had to base our dimensions off of readily available materials. And for production planning, we just wanted to really focus on manufacturing quality. Last year we were rushing things, and so our airplane was like kind of, it was a little warped and it was a little off, and so this year we wanted to make sure that we had a lot of precision when it came to gluing and letting everything set in place. We had to book a lot of labs. We've probably taken FabWorks and Rapid bookings for like the last month out of like every day so far. So if you've been trying to book, you probably see that it's probably full. I had to figure out where we're going to fly and who will fly. Colin Sledge is going to fly, and we go to Irvine Lake to fly. So innovation.
All right, so as Alex said before, not many people from last year returned to our team this year. We kind of had a blank slate. We really looked at last year's plane and took what worked from there and then kind of expanded upon those designs. So like we reused the same airfoils because there was nothing wrong with them. We used landing gear because there was, once again, nothing wrong with them. But we did try to make other parts more efficient. So for example, on the fuselage last year was really large. It had so much empty space, and we had to provide structure for it that didn't have any loads on it. So we really tried to minimize the amount of space for that. We did truss cutouts, and it's a lot smaller. Now, for the wing, we tried to maximize lift as much as possible, so we increased the chord length a little bit, which increases our lifting area, which in theory would also increase our lift in general. There are some things that we have to consider, as well as drag and weight, since it's a larger wing physically, it's going to be a little more heavier, but that's why we try to reduce the weight in the spars. And lastly, for the tail, we since the tail needs to be extended away from the fuselage, but our fuselage is a lot smaller, we decided to use a slender tail boom to extend that out. And we also sized the tail a little bit larger because last year, since there was a lot, in April there's a lot of wind turbulence, we wanted to size the elevator just so a little stronger, just in case of those effects. We also use heavy use of the laser cutter just to have precise cuts, because airfoils have lots of fine curves that we just need to be on top of things.
You'll need to move quickly.
Yeah, okay.
Time is up.
So here's our budget. I made a spreadsheet of our budget. Basically, I have a sheet within the spreadsheet for each invoice that calculated our total cost and approximated our total funding. And basically, I tried to figure out and determine what what incoming funds we were going to have for the next quarter, and just document everything just to make sure that everything is accounted for and we all get paid back for what we spent. Here's our timeline.
So for the timeline, we want to have a full assembly and salvage by week 4, and by week 5 and 6 we're doing plane revision, start manufacturing, so that we can fly by week 6. And then by the end of week 6, after we fly, we can do our final plane revisions or everything to make sure that we can finish our report by week 7, which is actually this Sunday. So in terms of progress, it's the same thing. We just kept track with everyone with lead meetings, team meetings. We did group chat, everything, making sure everyone's held accountable, keeping the deadlines. We want to make sure we kept all progress because the technical report is due the 24th, but our actual flight is the 6th. But we need to have a full plane without any revisions by Sunday.
And in terms of the bigger picture, I tried my best to do better than last year, and it was a lot of work, and it's been a lot of work, and it's been difficult. And so far, we've been doing better than last year, but at the end of the day, a lot of things don't go according to plan, and mistakes happen, and delays happen, and just, things come up that you just cannot account for. And so, going forward, the main thing about this and everything is just making sure that people learn from this so that they can take something away from it in terms of engineering and move on in the future and apply it to their future career or job or whatever it is that they have, and do better at that. So, we're all students, and we're not perfect, and this is just a little job now, but one day this will come in handy for people to use in the real world. So that's the end of our presentation. So.
Okay, thank you.